So now let's look at some questions under the parabola. But before I do that, there's something that I would love to indicate. So remember, we said when we have a parabola like that, meaning when it's on the y-axis, you're going to have let's say if the vertex is at the origin, you're going to have the equation to be x squared being equals to 4py. Okay, and that means when the vertex is not at the origin, you're going to indicate it as x minus h squared is equals to 4p y minus k, like that. Okay, so what I'd want to indicate is how you find the focus and how you find the directrix. Okay, because that's one of the most important part. Then again, let me indicate it when it's on the x-axis, meaning it's like that or like that. The equation is going to be like y minus k. I'm indicating when it's not at the when the vertex is not at the origin. It's more like general. So that would be squared is equals to 4p. That would be x minus h there. Okay, so for this one, okay, for the first part, our focus, okay, our focus our focus is going to be h comma, okay, our focus is going to be h comma k plus p, like that. Okay, then for this part, um, our focus our focus is going to be h plus p comma what comma k, like that. Then what about the directrix for this one? It's going to be y is equals to uh, k minus p, and this makes a lot of sense because if you have your parabola like that, meaning the equation of the directrix is just going to be cutting the y-axis like that. So this is just going to be y minus what? Y is equals to k minus p. Okay, that means the equation for the directrix for this part, we are going to indicate it using x because it's going to cut x-axis, which is going to be equals to h minus what? H minus p. Okay, so remember for this one, if your p is greater than 0, okay, if your p is greater than 0, it opens upwards like that. Okay, if your p is less than 0, meaning it opens downwards. Then for this one, if your p is greater than 0, meaning it opens to the right. If your p is less than 0, meaning it opens to the what? To the left there. Of course, here we're just talking about the basic xy plane, but when talking about when you start rotating it, that's going to be a different that's going to be something that's a bit different there. Okay, but we'll just focus on this part for now. Okay, so let's get to look at some questions. We see how we can go about them. Okay, so here are some questions. If you look at question two, okay, if you look at question two, this one here, uh, if you look at this part of the question two, it's that's a parabola, of course. It says in each of the following parabolas with the vertex at the origin, find the focus, directrix, and hence sketch the graph. Okay, how do we go about this one? So I'm going to pick two from these. Then we'll also look at one where the vertex is not centered at the origin. So I'm going to pick the first one. Uh, I'll pick the first one that has x squared is equals to 2y. Then I'm also going to pick the last one, which has y squared is equals to minus 4x there. Okay, let's see how we can find the focus, the directrix, as well as sketching. Let's see how we can go about this one. So the first one has been given as x squared is equals to, okay, is equals to 2y. Okay, so the first thing that we have to determine is the focus, but remember to say for this one, the focus the focus is supposed to be indicated using f here, meaning it's going to be h comma what, k plus what, k plus p. But in this case, our k is equals to what, our k and our h is going to be equals to 0. So meaning our focus is supposed to be 0 comma what, 0 comma p, like that. Okay, so how do we determine our p? Remember to say initially the equation was supposed to be x squared is equals to 4py. So meaning here where we have 4, like 4p is simply equals to what we have right here, which is a what, which is a 2. So you can divide both sides by 4 like that. So you determine that your p is equals to 1 over what, 1 over 2. Okay, so meaning your focus is a 0 comma half, which is 1 over 2. Okay, what about the directrix? Okay, so for the directrix, remember we just indicated using, since it's cast the y-axis, it's just going to be y is equals to k minus what, k minus p. But remember our k is 0, so your y is going to be equals to minus p, which means it's what, minus half, which makes a lot of sense because it's just halfway in between, like, yeah. So it's like you're going to have your 0, then you have your positive 1 over, more like positive 1 over 2, then coming down you're going to have negative 1 over 2, where you have your directrix here, then here you have your focus. Okay, so that's the directrix right here. Let's sketch this. Even makes it a bit easier, or let me say a whole lot easier, because we have already determined the important part of the of the parabola, which is the focus as well as the directrix there. So remember, we are told that this is centered at the origin. So meaning, not centered, but the vertex is at the origin. So we are going to have our vertex at that point. So it's going to be something like that and something like that. So at this point, I'm going to indicate 0, comma what? 1 over 2. 1 over 2, which is my focus. Then here we are going to have our directrix there that I've put in green. Uh, which we can indicate to say this is y is equals to negative 1 over what, 1 over 2, and that is the graph there. Okay, let's look at the second part, or rather the second question. Okay, so the second question is slightly different from the first one, in that it's not only on the y on the x-axis, but it's that it has a negative. But it's interesting. Now let's check it out. So we have y squared is equals to minus 4x. So remember, for us to determine our focus for this one, our focus is going to be, it's more like it's supposed to be h comma not like that. It's supposed to be h. It's just supposed to be h minus p, or h plus p. um, you got it right. It's h plus p, comma k there. But remember, um, our our h and our k is 0. Okay, and again, before even go any further, you observe to say, not only is it on the x-axis such that it's either like it's like this or like that, we're able to note to say this is eventually opening to on the left this side, because what we have here is a negative. So because p is a negative, meaning it opens on the left. Okay, so we have meaning the focus is just going to be p comma 0. So now let's determine what our p is going to be. So remember, we are saying 4p is equals to what, minus 4. So we divide both sides by 4 here, 4 like that goes. So we eventually get to say our p is equals to negative 1. So we're going to say our focus is at negative what, negative 1, which makes a lot of sense because it opens on the left. Okay, so remember, we have gotten to say our p is equals to negative 1. So what about the equation of the directrix, which casts the y-axis? Just going to be y is equals to, initially it's supposed to be equals to it's supposed to be h minus p, but because our h is 0, okay, so it's just going to say x is going to be equals to minus what, minus p. But remember, our p is negative 1, so we're going to say x is equals to negative 1 there, meaning the equation of the directrix x is going to be equals to positive 1. Now let's graph. Okay, so long you do everything right, everything's just going to be coming out okay. Okay, so I know to say it is opening on the left, so that makes it easier for me. I'm just going to do that, then at this point I'll say that is where my negative 1 is, so meaning that's where my focus is. So at this point, this we have negative 1 comma what, comma 0, this is our focus. Then on the other side, more like halfway, kind of. Is it halfway? No, like the same distance from this point to this point, and we just add it from 0 going the other side. You're going to have this, that's a directrix right there, which is x is equals to positive 1, which is that one there. Okay, So now let's try to find questions where it's not centered at where the vertex is not really, why do I keep on saying centered? Okay, where the vertex is not at the origin. Let's try to find such questions. Okay. uh, okay, there we have it. Question 5, there it is in the red circle there. Question 5 says, find the parabola's vertex, focus, and directrix, and hence sketch the parabola given that. So we only have two questions, so I believe we have to take both of them. Okay, we have to take both of them. So the first one, uh, just write it down. The first one is y plus 2 uh, squared is equals to 8x minus 1. Then the other one has x plus 1 squared is equals to minus 4. Then y minus 3, like that. So we have to find the vertex. We have to find the focus. We have to find the what? The directrix. But I believe this is easy for us. So looking at the first one we have been given as y plus 2 squared is equals to, we have 8 x minus 1. Okay, so now first of all we have to find the vertex. Remember, the vertex has the coordinates h comma what, h comma k. But remember, this one initially, the way it was before, we had to write it in that manner. It was y minus k squared is equals to 8, then x minus what, x minus h, like that. So we just have to determine what our k is and what our h is. So if you observe here, I'm supposed to have minus 2, but because it's plus 2, it indicates to me that my 2 was a negative, so means it was negative 2 for it to be positive. So I can say my k is equals to what, negative 2. Negative 2. What about our h? Our h remains what, remains positive 1. So our h is equals to what, positive 1. So it tells us that our vertex is at the point 1 comma what, 1 comma negative 2, right? Like that. Okay, so now what else do we have to find? We have to find the focus. So for this one, remember, when it's oriented on the x-axis, our focus, we say focus, you are supposed to be h plus p comma what, comma k. Okay, now we already have our k and our h. What is remaining is for us to find what, for us to find our p. So that's h plus p comma k. We have to find our p. So remember, we still get our p from here. We still say 4p is equals to what, is equals to 8, meaning our p is equals to what, is equals to 2. So we're going to come here and say the focus f will be, our h is what, our h is 1, okay, plus our p, which is 2, comma, our k, which is negative 2. So we're going to have our focus being at 3 comma negative 2, like that. That is very, very important. Yeah. So what else do we have to find is the directrix. Okay, so the directrix here, we're going to say it is going to be x is going to be equals to h minus what, h minus p. So x is going to be equals to, our h is 1 minus our p, which is what, 2. Okay, 2. I said our p is equals to 2. Yeah, so meaning our x is going to be equals to negative what, negative 1. That's where our directrix is going to be. It's what, the equation is x is equals to negative 1. So now let's do the sketching. So at least we know this is oriented on the x-axis, which makes it uh, easy for us. But again, looking at the fact that our p is positive, meaning it opens what, it opens on the right. But first of all, we have to come and indicate where the vertex is and where the focus is. So we observe to say our focus is at so if we have, let's say, 1, 2, and 3 there, then we have negative 2 on the y-axis. You have negative 1, negative 2 there. So let me just indicate y and x there. Okay, so we have our focus at okay, I'm still supposed to go in the negative, I think, on the x. So you have negative 1 there for the directrix. Okay, so now let's look at the focus. The focus is at positive 3 comma negative 2. This is positive 3, then negative 2 there. So it will be, I believe, somewhere here. That's where we have our what, our focus. Then our vertex is at 1 comma negative 2, which is somewhere at this point. Okay, so now you observe to say this is going to be something like that, but for like when you're doing mathematics, it's very important that you get the correct details. So again, it's important that you know what the y value is going to be. Okay, what the y value is going to be, like is it y value? No, what the x value is going to be, because this graph is going to cut the x-axis, and at any point in this x-axis, our y is what, our y is 0. So we just have to replace where there is y, we put 0 in this equation, so that we know where we are going to pass. We don't just want to put it anywhere. Okay, so we can say we have 0 plus 2 squared. I'm just substituting where there is y, I put 0 there, because at any point here in this line, our y is 0. So this is going to be equals to 8x minus 8, like that. So this is going to give us 4 is equals to 8x minus 8. Okay, so this is going to be, you correct the like terms, this is going to be 4 plus 8, that would be 12, I think, is equals to 8x there, divide by 8, divide by 8, like that. Okay, what are we going to end up with there? Okay, so here we have x is equals to what do we get? X is equals to that is 4 into 12 is 3, divided by 4 into 8, it's 2. Okay, that's 2. Then I think that gives us 1.5, if I'm not mistaken. So if this is 1, then 0.5 is somewhere here. Okay, so it can be somewhere there. So when you draw the graph, meaning you're going to pass at that point. Now remember, what if I just had to put it like that? Meaning if the person who is marking my paper is very accurate, they are going to disqualify my graph. Okay, I'm going to lose marks, so it's going to be something like that. Okay, so that's a graph for that question. So now let's look at the last part, the other question, I mean. So the other question, we are given x plus we are given x plus 1 squared is equals to minus 4. Then we have y minus 3, like that. So first of all, I have to determine the vertex. Remember, the vertex is at the point h comma what, h comma k. So it's just a matter of you determining what your h is and what your k is. So I think we can clearly see to say our h is negative 1, because for it to be positive 1 here, meaning it was negative, so it had just had to multiply out. So we have negative 1 comma, our k is what, is positive 3. That's the vertex. Then the focus, so the focus for that one, it simply means our focus is going to be h comma what, h comma k plus p. Okay, so first of all, we have to determine what our p is. So remember, we are going to say 4p is going to be equals to negative 4, as we have it here. Okay, so meaning our p is going to be equals to negative 1. Yeah, and in the previous question, I forgot to indicate where the directrix was. Things. Let me try to just to show it um, for the sake of clarity. But I believe you have already perhaps figured it out. Okay, so remember this was coming like that. Then we had the equation of the derivatives to be negative 1, so meaning it's going to be somewhere here at negative 1. Okay, something like that. At that point, that's where we have what, x is equals to negative 1. So you observe to say from this point, okay, to this point, the distance that we have is 2, because like we have 1, 2. Then again, you can move from this point to the focus. The focus is at 3, which is also what, which is 1, 2. That's where the equidistant part in the definition really makes a lot of sense. Okay, so we can get back to the question that we were doing. Okay, so we said the equation is The equation is x plus 1 squared is equals to minus 4 y minus 3. So we said our vertex is at negative 1 comma 3. Then we said our p, we determined that our p was equals to negative 1. Okay, so meaning our focus is going to be h comma k plus p. Our h is negative 1 comma k plus p. Our k is 3, then plus p, which is minus 1. That just gives us what? Gives us a 2 as our focus. Then for the directrix there, our directrix, you're supposed to say y is equals to what? Y is equals to x, not x, but k minus p, rather. K minus p. And we know that to say our k, okay, our k is 3 minus our p, which is negative 1. So meaning our y is going to be equals to what? It's going to be positive 4. Okay, so now let's graph this. So you can see it's very quick. It's very easy to find it, to answer such questions actually. So one thing that we also observe is that this opens downwards, but we have to determine exactly where it's located, okay, because the vertex is not at the origin. So now we can see that the vertex is at negative 1. So meaning we're going to have negative 1 here. Okay, we have negative 1 at this point. We have negative 1 here. Then we have positive, that's positive 3. So we have like 1, 2, 3 in the y-axis. So when you come here, okay, at somewhere at that point, you're going to have what? You're going to have your vertex somewhere here. Then the focus is at negative 1 comma 2, of which is somewhere at this point, like that. Then what else? So I think I can erase this. I will not need it anymore. What other details do we have? So I believe that's all that we need from what we have. But of course we have, like, at 4, at 4 here, somewhere here, we have what? We have the equation of we have the directrix. In short, we have the directrix there, so we can indicate it like that. And we know the equation we have said is what? It's y is equals to what? Is equals to 4, which makes a lot of sense. Then here, to say this opens downwards like that and like that. But again, remember, you don't know exactly where, like when you do this and when you do that, you don't know exactly where you're supposed to cut the y-axis, and you don't know exactly where you're supposed to cut the x-axis. So you're supposed to to say, like, let me just find the first part in fact, because I know to say for this on the y-axis, x is 0 for all values. Okay, so it basically means I'm going to set my x to be equals to 0. So meaning, like, 1 squared, that would be a 1, is equals to, that would be minus 4y plus what? Plus 12. Okay, so I take it on the other side. I'm going to have like 4y is going to be equals to 11. So divide by 4 there. So in terms of decimal places, what do we get? I believe it's 2 point, that's 11 divided by 4, that's 2.75, which might be somewhere here. So we now know where it's going to pass, like somewhere there. Then coming down like this, where it's going to cut the y-axis, we also have to set our x to be what? We have to set our y to be 0. So if you put 0 here, you observe to say, then this side is going to be x squared, okay, x squared plus 1 plus what? Plus 2x. Okay, let me just write it as plus 2x plus 1 is going to be equals to, when you set y to be equals to 0, that's going to be 12 there. Okay, so you observe this is just going to be x squared plus 2x, then that would be minus what? Minus 11 is equals to what? Is equals to 0. So you can, I don't know, there you can manage to factorize that one, or you can use the formula method to find what the values of x are, for you to know exactly where it's going to pass. Yeah, so that you don't just use guesswork for you to put them anyhow. But if you really want to give your work to be detailed, it's important that you indicate exactly where the graph is cutting the x-axis as well as cutting the y-axis. So that's all in this video. Thank you very much for watching.